Okay, hello everyone. Okay, 今天呢，我就会讲你们 Chapter Seven. Okay, because we are short of time, so 我就会用这样的方式来教你们的。Okay，如果你们有什么不明白的，你们可以随时来问我。Okay, so basically Chapter Seven 呢，它会有3个 subtopic 的玩，there are 3 subtopics altogether. Okay, in these 3 subtopics, we will learn what is black body. Okay, then what is the wave particle duality. OK， 还有就是我们会学一个 theory，what we call as photoelectric，Einstein's photoelectric theory。OK，so 在这个 chapter 呢会有一点点的 calculation，OK，可是只要你 follow the formula，OK，那这样你就可以 you are able to answer the questions already。OK，so 我们就现在进入 the first subtopic，it will be what do we call it as Okay, so the next slide, okay, sorry, the first we are going to learn about what is quantum theory of light. Okay, so 在这边呢，我们 before that 我们有学会讲说，我们的在 chapter 5 from 4的时候，我们就学到说 what is electromagnetic spectrum. So electromagnetic spectrum is a spectrum that consists of all the 7 types of wave with different frequency and wavelength. So all these 7 waves, they are arranging in increasing frequency but decreasing wavelength. OK， 所以在这边我们就要 focus on what is the visible light。OK，visible light 我们知道就是它有 7 colors of light， 就是我们的 rainbow color， 红、橙、黄、绿、蓝、靛、紫。OK，they are arranging according to the increasing frequency but decreasing wavelength. 所以你看红色 will have the longest wavelength, okay, but the lowest frequency. Then 紫色就 has the shortest wavelength but the greatest highest frequency. Okay, so 在这边呢 ，OK， 我们就会学的讲说 ，OK，any object, OK, that is above the absolute zero, OK， 就是减273 degree Celsius， 它就会 able to emit electromagnetic radiation。OK， 不管什么 object 都好，就好像你的钱包啊、你的handphone 啊，全部都可以 emit electromagnetic radiation 的。OK， 好像 low temperature 的。OK， 如果 object with low temperature， 它就 able to emit wave with lower frequency， 就是 radiation with lower frequency 咯。For example, radio wave 还是 microwave。Then object with a higher temperature 的就 able to emit wave with a higher frequency。OK， for example, visible light 还是 UV rays。OK，so visible light 算是 high temperature。OK，so 我们知道讲说。Object at any temperature 都可以 emit electromagnetic radiation 的时候，我们就会学到 what we call as a black body. So what is black body? 是一个 idealized, is an idealized body that is able to absorb all the electromagnetic radiation. 就说是一个 body that is able to absorb all the electromagnetic radiation falls on it. So what happens is 它 absorb already， 它就会 emit it out as a thermal radiation. OK, thermal radiation depending on its temperature 啦。OK, so 就是说它到了 certain what we call certain temperature 的时候，它就会 emit out 这个它 electromagnetic radiation that is absorbed by the black body, it will emit it out as a thermal radiation. OK， 这个 thermal radiation 是有 energy level 的啦。OK， so black body radiator, OK, emits thermal radiation at all wavelength. 就是说 any wavelength 都好，只要它到了一个 certain 的 temperature， 它就可以 emit 这个 thermal radiation already. So the most common black body in natural phenomena 就是我们的 sun， 还有我们的 blue star. OK。So 这个 graph 呢是来跟你讲说，其实每一个 star， 就 for example 我们的 red star，OK， 我们的 white star，sun， 还有我们的 blue star，OK， 它们都会 absorb all the electromagnetic radiation at all wavelength。可是它到了一个 certain temperature， 它 at a certain wavelength， 它就会 emit out the highest energy level。OK，so the energy level，OK, of the black body radiation is not shared evenly by all the wavelength. 就是说它不是每一个 wavelength 它都可以 release 的那个 energy 的 ，OK， 它不会 release all the same energy， 就是same certain wavelength it will release the highest energy level. Okay, so the intensity becomes zero, okay, nearly zero at a short wavelength, okay, at a short wavelength high frequency side. 就是说它在这一边的时候 ，okay， 它是 nearly to zero 的 ，okay， 可是慢慢当它的 wavelength increase 一点点，不是太多啦，你看它太多的时候它就会 drop 下来了，所以呢 energy level it will be able to release 还是就 the thermal radiation is able to release at a higher temperature, okay, and also a shorter wavelength. 记得 short wavelength and high energy, okay, to produce high energy level, okay, and also 它的 energy to emit the highest energy level also depending on the temperature, okay, temperature 它 hit 到它的 temperature 它就会 peak 了的咯 ，okay， 可以啊。So 这边就是一个 video， 我会 show 给你们看 what do we call it as the black body. Okay， 等一下。Okay, so let's see here.
This video will explore some of the characteristics of blackbody radiation. In doing so, we will explore an object emitting and reflecting light in both visual and infrared bands. 3 types of spectra are discussed in introductory astronomy classes: continuous, absorption, and emission. Continuous spectra are often called blackbody spectra. Continuous spectra have all wavelengths present, absorption spectra have a few wavelengths missing, and emission spectra have only a few wavelengths present. Kirchhoff's laws describe the types of spectra produced by various objects under various circumstances. One of Kirchhoff's laws is that a dense gas or a solid, like a light bulb filament, produces a blackbody spectrum. A black body is often pictured as a cavity with a small opening. Light that enters the cavity through the opening is reflected from the walls of the cavity many times until completely absorbed. An ideal blackbody absorbs all of the light that is incident upon it. Objects that are good at absorbing radiation are also good at emitting radiation. Thus, an ideal black body is also an ideal radiator. Note that ideal black bodies don't exist in nature, but some objects come pretty close. We normally describe a blackbody spectrum with the Stefan-Boltzmann law and Wien's law. The Stefan-Boltzmann law describes the total amount of energy produced in the form of light, seen here as the area under the curve. Wien's law identifies the wavelength of light at which the most light is produced, seen here as the wavelength at the peak of the curve. As a blackbody's temperature is increased, the total amount of light energy emitted increases and the peak wavelength moves to a shorter wavelength of light. The apparatus shown here is simply a block of aluminum with a cavity, a hole drilled in it. Note that the outside surface of the block is reflecting primarily visual light and emitting primarily infrared light because of its cool temperature. The hole appears dark because no visible light is getting reflected by it. What do you think the block and hole will look like in infrared light? Your instructor will now stop the video. Before we take a look at the block with an infrared camera, please make a prediction and explain your reasoning on a piece of paper. Let's now switch to an infrared camera. Note that the block is dark. This occurs because at room temperature, a blackbody spectrum peaks in the infrared. Less light is being emitted in the infrared than is being reflected in the visual by the block. But note that the hole appears quite bright. The entire inside surface of the cavity is emitting infrared light, but it is only coming out through the hole. Thus we have much greater intensity than from the outside surface of the block. Note that we have heated the block to minimize the effect of infrared light emitted by the demonstrator reflecting off of the block. Let's bring in 2 other blocks made out of brass and steel that have holes drilled in them. Note that the outer surfaces of all 3 blocks appear quite different depending upon how the material of their composition reflects incident light. All 3 holes still appear dark. Visual light is going in and reflecting around until absorbed, but at room temperature, very little visual light is being emitted and coming out. Let's switch back to infrared light. Note that all 3 surfaces still appear differently. The 3 substances emit and absorb radiation differently, a parameter physicists call emissivity. But note that all 3 holes still appear bright, and equally bright. Blackbody radiation does not depend on any characteristics of the emitting body except temperature. More teaching materials are available on the web at astro.unl.edu.
Okay, so from 那个刚才我 show 你的 video 哈，你会发现到讲说 ，actually 它就有点像是 emitting infrared。Okay, so 就是说 black body 就像我们的那个 can。Okay, Coca-Cola can 还是我们的100 plus 的 can 这样子，你开起来有那个 hole，light okay or electromagnetic radiation it will enter okay the can through the hole, then 那个 hole 就在那个 can 里面 it will absorb all the the electromagnetic radiation, then it will emit out the thermal radiation. So that's why 你刚才在那个 infrared 的那个 device 下面的，你就会发现到讲说中间那个洞是亮的，其他的旁边的是暗的。为什么呢？那个 thermal radiation is coming out from the holes, okay, at the center part, okay, 所以你就会看到中间是亮的。Okay. So 在这边呢，我们的那个 black body is able to apply in our daily life. Okay, for example, nowadays very commonly used is the thermographic camera. Actually now 很多international airport, okay, 日本的、韩国的、Malaysia 的好像是也是有 ，even actually 恒毅 itself 也是有这个 what do you call as the thermographic camera， 它也是 apply the black body 的，因为我们知道我们的身体也是可以 absorb 那个 electromagnetic radiation， 还是 in another words 讲说我们的身体也是可以散发出那个 thermal radiation 的 ，OK 那个热气 ，the heat is able to absorb，OK， to able to be detected by the thermographic camera。Okay, to show our real-time temperature. 还有就是我们的 oven heating element. Okay, 这个 heating element 当你热起来的时候，它就有那个 radiation. Okay, the electromagnetic radiation being absorbed by the element already, 它就会 release it up as a thermal radiation. 所以你就会感受到那个热气。还有就是我们的filament, okay, the bulk filament 也是有 apply 到 black body 的。Okay, next. 刚才你有看到讲说 black body 其实就是好像刚才你看到那个 video 有 absorption, discretion, absorption, discretion 跟那个 emission， 你会发现到讲说 absorption black body 它会 absorb all the electromagnetic radiation at all wavelength。OK， 证明了其实 electromagnetic spectrum 呢，它是有整个的那个 series of wavelength 的。OK， 在那个 spectrum 里面，可是呢，在这边呢，我们有 what we call as the quantum physics theory， 它就没有真正用到 fully in about the what we call electromagnetic spectrum already。OK， 所以我们先来看一下 ，in a hot object， 我们有 electron vibrates rapidly and randomly in any direction and produces light。So hotter object higher energy， 就是说我刚才那个 video 里面有讲了。它的那个 energy level is just depending on the temperature, not wavelength, not what we call frequency. Okay? 可是 electron that vibrate at the same frequency will have the same energy content. Okay? Temperature of the black body increase, the intensity will increase. OK， 这个是 intensity also increase。intensity 这边就是应该是 what we call as the 那个 light 啦，就是那个 light energy。OK， 所以这边呢有几个 physicists that involves in the quantum theory。OK， 我们有的就是第一个就是 Isaac Newton 咯 ，Isaac Newton， 有 Thomas Young， 有 John Dalton， 有 J.J. Thomson， 有 Max Planck、Albert Einstein、Niels Bohr 跟 Louis de Broglie。OK， 在这边呢，我们会比较 focus on Max Planck，OK，Albert Einstein 跟 Louis de Broglie。OK，I'm sure that before that 有其他几个 Thomas Young 那些你们在其他的 subject 已经有学过了。OK，Max Planck 就讲说 introduce the concept of quantum discrete energy。等下 what is about discrete energy？ 等下我就会 explain。So the electromagnetic wave emitted by the black body is in discrete form known as quantum of energy. Okay, the energy in each quantum is directly proportional to the wave frequency. Okay, 这个就是 Max Planck 讲的啦。So the the intensity of the radiation is low for high frequency wave. Okay, so next 就是 Einstein 就 introduce photons. OK， 就是说它不把 electron 当成是一个 particle， but 它把它当成是一个 photon。OK， so the photon energy is directly proportional to the light wave frequency. OK， Einstein quantum theory of light was successfully in explaining the characteristic of the photoelectric effect that could not be explained by classical theory. OK， 还有最后一个是 Louis de Broglie。OK，Louis de Broglie 呢就是 introduced what we call as the wave particle duality 的。So what is wave particle duality？ 等一下我们就会学到。OK，so 我们先会学到 Max Planck 讲过的 what we call as the quantum of energy。OK，quantum of energy is the discrete energy packet and is not continuous energy。Okay, so discrete energy packet depends on the frequency. Okay, frequency of the waves. Okay, so continuous spectrum has a combination of all values of wavelength. 可是呢，我们的 quantum of energy 呢，只是有 line spectrum， that has a discrete value of wavelength or frequency, okay, that are from a state of cool gases. OK， 就像这个 ，these are the two differences. OK，continuous spectrum 呢，就是你看它的那个 wavelength 呢是会有 energy in all level of wavelength and all frequency. However, for light spectrum 就是它的 discrete energy。OK， 就是 another word 就是 quantum of energy 了。It's produced by excited atom at a series of color light at a unique wavelength。你看，在 certain wavelength 它才会有 energy being produced 的，不是每一个 wavelength 它都会有 energy produce， 所以呢才叫做 discrete。discrete 就是discontinuous 的意思，就是还是 specific 的意思。OK， 就是说它独特的，只有一个独特的 wavelength 才会 release 那个 energy 的。OK， 所以这个就是 quantum of energy. So each element produces a spectrum with a series of its own discrete distinctive light. OK 啊 ，OK。So 在这边呢 ，based on the Max Planck and Albert Einstein's quantum theory， 我们就知道讲说 ，light energy exists in the form of energy packet known as photons。OK， 就是说，因为 the electrons 它会absorb the heat, then it will vibrate。OK，vibrate 了后，就是说它 absorb 那个 electromagnetic radiation。Then 它就 emits out as a thermal radiation 这样子 ，then 这个 thermal radiation 就会有 energy level。OK，so 这个 energy level 呢，就是 it will be applied in the quantum of energy， 就是说在 certain wavelength 才会有 produce the specific energy 的。OK，and this light energy exists in the form of energy packet known as photon。So 就是说 quantum of energy 也是可以叫它叫做 photons。OK，photons are light energy transferred in a quantum energy。OK，so 你这个 photon energy is actually directly proportional to the frequency of the light waves。OK，虽然说 discrete 是只有 specific 的 wavelength 才会有这个 photon energy， 可是呢，当你的 frequency increases 的时候，你的 quantum photon energy 也会 increases。OK， 所以呢，如果你把这个 relationship 变成一个 formula 的话，它就会变成这样子 E equals to HF，where 这个 H 是一个 constant， 就是 Planck's constant。这个考试一定会给你这个 what do you call 这个 value 的，就是 6.63 times 10 to the power negative 34 JS negative 1。OK， JS negative 1啊。OK， 就是不是 JS negative 1，是 Joule second。OK，Joule second。OK， 这些我要你们自己去看了 OK， 自己去看它的那个 calculation， 它有 step by step 跟你讲怎样做。只是我要你们 focus on 这一边。OK， 如果它有给你那个 wavelength。OK，in nanometer 的话 ，you must always remember to convert your wavelength into meter， 因为我们知道 nano 是 stands for times 10 to the power of negative 9， 所以呢，你这边你要放这样子，不用把它换成 standard form， 你可以直接就是400 times 10 to the power negative 9， 你就已经把它 convert 变成 from nanometer 变成 meter already， 就这样子，不要做这样多。OK，then 这边我们有一个 formula，OK，E is equals to HF， 可是为什么会有这个 HC over lambda 呢？因为我们知道讲说，其实light is a kind of wave，OK，and here light is as a photon which will produce the photon energy。所以呢，在这一边呢，你的 frequency 就是那个 frequency of the light wave。我们知道说，如果说是一个 wave 的话，我们的velocity is equals to F lambda。So if let's say it's a light wave, it will be traveling in the speed of light， 所以就是 C equals to F lambda。所以如果你把它 substitute 进去这个 F 里面的话 ，F is equals to C over lambda， 所以你这边就会拿到 HC over lambda 这一个 formula。OK， 所以这个就是这个 formula 的来源啦。OK， 所以这个你们可以自己回去看。 OK， so 现在第二个就是 wave particle duality。OK， 我要讲 light， 因为它是一个 wave，OK， 它会show the phenomena of the diffraction and interference。OK，object 其实很多的 object 都是有 particle property。OK， 因为它有 momentum， 因为 any object 你给它滚动的话，它就会有 momentum， 因为有 motion， 它就有 momentum。momentum 它有 kinetic energy， 还有它可以 collide with each other。所以呢，如果你把这个 apply in the light particles 的话，其实呢 Louis de Broglie 就讲说 predict that the wave characteristics can be shown by the light particles such as electrons。所以呢，这边呢，我们就 focus on electron， 其实它有 what do we call as the wave particle duality， 就是说它有 characteristics of the particle， 它也有 characteristics of the wave。OK， so 在这一边我们知道呢 ，OK， lambda is equals to h over p。OK， h over p。OK，I mean from here 我们就知道讲说 lambda is equals to h over p。OK，where p is what we call as the momentum of the particle. So in short, 这个 formula 其实是在 explain the what do we call as the wave particle duality. OK， 就是说一个 electron okay, that is being excited by a certain frequency of the light wave. OK， 它也会有 what do we call as the particle properties, which is because it is moving, it has momentum. Then 它有这个Planck's constant， 就是一个 constant 的。OK， so from here 我们就知道讲说 the greater the wave, the momentum, the shorter the wavelength. So it's inversely proportional 的。OK， 所以在这边可以看到。OK。So since the value of momentum of the particle can be determined by P equals to mv， 所以呢，我们不只是有这个 formula， 我们也可以把它就是 derive to another formula， lambda is equals to h over mv， where mv 就是你的 momentum。OK， 可以啊。OK， 为什么我们讲说 electrons is able to perform or is able to show the wave particle duality？ 因为说我们知道，其实呢 ，light 它可以 being diffracted。当你把一个 light passes through a single slit， 还是一个 holes 的那个一个 hole 的话，你就会 produce 这一个 light 的那个 diffraction 的那个effect 出来。可是如果你放啊，你看啊，在 electron 里面，它也是有 show 这个 diffraction pattern through a thin layer of graphite. So from this experiment, 我们就可以讲说 electron is also is showing the wave particle duality. So 它有 wave 的 characteristics， 它也有 light 的 characteristics. Okay, so this confirm the de Broglie hypothesis. Okay, 可是我们要知道 electron 跟 light， OK， 它怎样讲 ？electron 跟 light 都可以 undergo 这个，都有这个 wave characteristics。为什么我们要知道讲说 electrons has 这个也不，它是虽然说还是一个 particle， 可是它也可以 perform wave 的那个 characteristics based on 这个 wave particle duality。OK， 因为我们这个 light 跟 electron， 它们都是有 shorter wavelength 的，而且呢，我们的 electron 是更加 short。OK，up to nanometer short 这样子的。OK， 就是因为有这个 short 的 nanometer， it will produce a discrete what do you call a greater amount of the quantum of energy, photon energy. OK， so 呢，它就会给你 a greater, a more OK， 那个怎样讲？你看啊，这个是 what do you call it as electron microscope， and 这个就是 optical microscope。你看 optical microscope 它 produce 出来的那个，sorry， 它这个是 optical microscope， 这是 electron microscope。OK， 你看 optical microscope 你可以看到这样小的 red blood cell 了。However electron microscope 因为它有 short 的那个 shorter wavelength，OK，shorter wavelength。所以呢，它会produce a higher magnification。 ，OK， higher magnification，OK， on this electron microscope。that's why 你可以看到这样大个的那个 Rainbow cell over there。所以呢，就是因为有不一样的那个wavelength，it is having much shorter。OK， 而且它有 producing what I mean， 它有 showing the light and also the wave 的那个 characteristic， 所以它才会有这一个what do you call 这一个image 的那一个 produce。OK， 所以在这边呢，我们就知道讲说，如果是 the light energy transmitted in the energy packet 的话，就是 E equals to HF， 还有就是 E equals to HC lambda。OK， 所以呢，如果我们要知道讲说 n photon is being emitted per second，OK， in a power， which is the total energy transferred。So E power 啦，如果我们要找 power 的话 ，OK， power 就是 NHF，OK， NHF， 而且我们也可以把这个 F convert 变成 C over lambda， 所以有 NHC over lambda。Okay, so both light and electron have the wave particle duality as they possess both wave and light properties. 所以不只是 electron 有 wave particle duality，OK， 我们的 light 也是有这个 wave particle duality。Okay, so all types of electromagnetic radiation and the radiation in subatomic particle also have these duality properties. Okay, and OK， 这些你们可以自己回去再看，有什么问题你们可以再问我，都是 based on 我们刚才我 show 你的那个几个 formula 的。